Okay, so the third problem today, number 52, is another limiting reactant problem. This is iron 3 oxide and hydrochloric acid making iron 3 chloride and water. Okay, so if I take a look at this, the question says how many grams of water can be made, right? I always circle what this question is asking me. When 100 grams of iron 3 oxide and 100 milliliters of 3 molar HCl are reacted. Okay, remember that when last chapter we learned a bunch of ways to do stoichiometry problems no matter what we are given. We talked about if we are given atoms, if we are given grams, if we're given volume of a gas at STP, volume of a solid or liquid, or volume of a solution. That's what I'm given here. So I'm going to have to use molarity. But the general process for these is going to be the same. I'm going to start with 100 grams of iron 3 oxide and figure out how many grams of water I can make. Then I'm going to do a problem with 100 milliliters of 3 molar HCl and how many grams of water I can make. And then whichever one of those is the lowest is going to be the theoretical yield, and the reactants that gave me that is going to be my limiting reactant. So let's start with, I circled it in red, so let's start with that. 100.0 grams of iron 3 oxide, Fe2O3. Right? The first thing I always do is convert to moles. The molar mass of that is 159.7 grams. Using the coefficients from the balanced chemical equation, 1 mole of Fe2O3 will produce 2 moles of water. And the question is just asking about the grams of water, the mass of water. So the molar mass of water, I know, is 18.016 grams. Right? I haven't been talking about this, but our units are always diagonal down matching so that they cancel. And my final answer here is going to be 22.56 grams of water. So that's saying if I use up all my iron 3 oxide, I can make that much water. Okay, so now what about if I use the other reactant, 100.0 milliliters of HCl. Well, the first thing, I know molarity, right? Anytime I see molarity, I know that I can change that to 3.0 moles, and that's how many moles are in 1 liter of solution. So the first thing I'm going to do is take that 100 milliliters and convert it into liters. And then 1 liter of solution, 3.0 moles of HCl. And then according to the balanced chemical equation, 6 moles of HCl will be required to make 2 moles of water. And 1 mole of water has a molar mass of 18.016 grams. And put that into my calculator and I get 1.802 grams of water. Well, that's much less than 22. So which reactant was my limiting reactant? So that was the reactant that gave me the least amount of product. So my limiting reactant was that 100.0 milliliters of the 3.0 molar HCl. And the theoretical yield is 1.802. I'm looking at this number here, just has 2 significant figures. So I'm actually going to round that to 2 significant figures. So 1.8 grams of H2O. So let's put this into our concluding statement here. So since the 100.0 milliliters of 3.0 molar HCl will produce the least amount of product, it must have run out first, and thus was the limiting reactant. Only 1.8 grams of water can be made before the reaction stops and the HCl runs out. And now we have that second half of the problem. How much excess reactant is left over? Right? Remember, left over means didn't get used. And excess reactant, That's the reactant that isn't the limiting reactant. So our limiting reactant was the HCl. So the other reactant, the Fe2O3, is the excess reactant. How much of that is left over? Well, we have to figure out how much did we start with. And I go back to the original problem. We started with 100 grams. And then how much did we use? I don't know. I got to figure that out. And once I figure that out, I will just subtract those two. How do we figure that out? We have to go back and start with the limiting reactant again, right? 100.0 milliliters, and then 1,000 milliliters is 1 liter, and then 1 liter of that HCl contains 3.0 moles. And then according to the balanced chemical equation, 6 moles of HCl will use 1 mole of Fe2O3. And I want to find the grams of Fe2O3, right? So 1 mole of Fe2O3 has a molar mass of 159.7 grams. Right? When I do that, I get 7.985 grams of Fe2O3 that was used. So I'm going to subtract 7.985 grams of Fe2O3, and that means what do I have left over? 92.015 grams of Fe2O3, iron 3 oxide. Now, I haven't talked about significant figures here, but right, I don't round until the very end. If I look back, right, this is a subtraction problem, so I'm looking at decimal places. 100.0 has 1 decimal place. Looking at this problem, the numbers that count, this would be rounded to just 2 significant figures or 1 decimal place. So then if I have 1 decimal place and 1 decimal place, I'm going to round this to 1 decimal place. So 92.0 grams of Fe2O3 is how much is left over. When students have difficulty with these problems, one thing that I will always go back to is, are you labeling your numbers, right? Because in this problem, we were using iron 3 oxide, HCl, and water. And if you're not actually writing what substance those numbers are referring to, it can get very confusing. Okay, you're going to have some more of these to practice for your homework.